I'm Anil Kumar. Welcome to my channel. Let me thank all the viewers and subscribers for taking keen interest in my videos and posting their suggestions. Now in this particular video, I'll discuss with you a complete test paper on probability. Let me thank all my students for sharing these questions with me. So I've taken 9 questions from this test paper. Normally 75 minutes are given to solve it. I might take about an hour explaining you all the concepts. I'll first share with you these questions. You can go through them, pause the video, answer them, and then look into my suggestions. Here is question number 1. Now it is on conditional probability. We are given probability of 2 events A and B, and for different conditions, whether these are independent events or dependent events, we need to find probability of intersection of A and B and probability of union of A and B, right? So this means when A and B happens, and this means when A or B happens, right? Either one of them or both of them. So that's your question number 1. Question number 2. A multiple choice test has 20 questions and 5 choices for each question. What is the probability of getting the next 6 questions correct by guessing? And question number 3 is, determine the probability that at least 2 people from 30 will be born in the same week, right? Are born in the same week. Question number 4. Bob has 2 boxes with contents of the box listed in the table. If he draws 1 ball from each box, what is the probability that they are both different colors? Question number 5. In a tennis tournament, Mike and John play 3 games and John's probability of winning is 55%. Draw a tree diagram for the 3 games. What is the probability that John wins all the 3 games? Determine the probability that John will win at least 2 games. And D is, determine the probability that Mike will win exactly 1 game given that John won at least 2 games, right? So go through this statement properly and then answer. Question number 6. A fruit stand has 5 apples, 8 peaches, 4 plums and 6 pears. If you pick 4 pieces of fruit at random, what is the probability that you select all peaches? What is the probability you select exactly 2 apples and exactly 2 peaches? C. What is the probability that you select at most 2 apples? Question number 7. The probability of Anil hitting bullseye is 70%. How many arrows should he shoot so that the probability he hits the bullseye at least once is greater than 0.995. Question number 8. A standard deck of cards is shuffled and 10 cards are placed on the table in a row. Your younger brother turns up these cards before you could stop him. Second card is ace of clubs, fourth card is 3 of diamonds, fifth card is 3 of clubs, seventh card king of hearts, ninth card queen of spades, and 10th card 9 of clubs. Knowing the cards that your brother turned over, what is the probability that the first card is a heart? What is the probability that the third card is a face card? And part C is, what is the probability that the third card is a club and that the sixth card is a diamond, right? Now the last question, question number 9. A survey was conducted to determine the watching preferences of TV shows. The following results were obtained. 20% watched DD, 16% watched IF, 14% watched JJ, 8% watched DD and IF, 5% watched DD and JJ, 4% watched IF and JJ, and 2% watched all 3 shows. If a person is selected at random, what is the probability that the person did not watch any of the shows? B. The person watches only one show. C. Person watches either DD or IF. D. Person watches DD given that the person watches at least one show. So these are the 9 questions. I hope you find interest in them. Try to solve them and then look into my suggestions. Now let us look into their solutions. Question number 1. Given probability of A equals to 0.58 and probability of B equals to 0.32, calculate the following. A. Probability of A when B occurs is 0.2 and A and B are not independent events. In that case, we need to find probability of A and B and probability of A or B, right? So probability of A and B, now in the case when they are not independent events, should be probability of A when B occurs times probability of B, right? So probability of A when B occurs is 0.2 times probability of B is 0.32. So you multiply them and get 0.3 decimal places, right? 0.64. Now part B here is we have to find OR. Now there is something common in between them, which is the intersection. So this probability has to be equal to probability of A plus probability of B, take away probability of A intersection B, correct? Now we are given probability of A, let me write here. Probability of A is 0.58 plus probability of B is 0.32, and we'll take away what we just found, 0.064, to get the answer, correct? Let's use calculator to find these answers. So 0.58 plus 0.32 minus 0.064 equals to, in decimals, 0.836. So that becomes the answer. Part B. A and B are independent events. In that case, we need to find A intersection B probability and probability of A or B. Now in this particular case, when they are independent events, then this probability is equal to probability of A times probability of B. Probability of A is 0.58, multiply by 0.32 to get your answer. Now in case of OR, since they are independent events, we'll find this, and this is the same thing, which is equal to, let me write here, probability of A plus probability of B, take away probability of A intersection B, correct? So this A intersection B we have to figure out before we find the other probability. So 0.58 times 0.32 equals to, in decimals, 0.1856. So we have to take away this from the addition of the other two, right? So we'll add the probability of A and B. So we can write this as equal to probability of A is 0.58 plus 0.32 minus 0.1856. So that is 0.58 plus 0.32 minus 0.1856 equals to, in decimals, 0.7144. So that is how we are going to solve the first question. I hope the steps are absolutely clear. Now let's take up the second one. A multiple choice test has 20 questions and 5 choices for each question, right? What is the probability of getting the next 6 questions correct by guessing? So in this case, probability, since there are 5 choices, so the probability of correct answer, let's say P, probability of correct answer is 1 over 5, since there are 5 choices. Now to get the probability of 6 in a row correct, so probability of 6 in a row will be 1 over 5 to the power of 6. So that becomes the answer, correct? So you can write down in decimal value, or you can write 5 to the power of 6 and write a fraction. This is equal to 1 over 15625. Correct? So that is how you could answer it. Question number 3. Determine the probability that at least 2 people from 30 will be born in the same week. Now, to solve such a question, what we should do is to figure out that all are born in different weeks. So we'll say all born in different weeks. So let's find how many cases will these be, right? So there are total 52 weeks, right? So that means for the first person to be born, we have 52 choices. Then we have 51. So the number of cases will in this case be 52p20, right? Since there are 20 students in this particular case, right? Determine the probability that at least 2 people from 30, so it is 30. Okay. From 30 will be born in the same week. So that is the number of cases which are favorable for different weeks. Correct? So now, what is the total number of cases? Total number of cases in our sample space is 52 to the power of 30, right? Since there are 30 students and any out of 52 could be chosen. So we can actually find the probability of different weeks. As equal to 52p30 divided by 52 to the power of 30. Right? Now, if I take away from 1 this probability, I get the probability that at least 2 people from 30 will be born in the same week. You get the concept, right? So the probability for at least 2 born in the same week should be equal to 1 minus this probability, correct? 1 minus 52p30 over 52 to the power of 30, correct? So that is how you are going to find it. I hope the concept is clear. So let's now calculate this value. So 1 minus 52p30 divided by 52 to the power of 30 is equal to, so we get a solution to this which is 0.999. Let me recalculate. Let me calculate it separately, right? So let's calculate this answer. We have 1 minus So let's calculate this. So we have 1 minus 52p30 divided by 52 to the power of 30, and that gives us 0.99997. So it's highly likely, correct? So it is highly likely, almost certain, that two persons' birthday will fall in the same week. Correct? Let's move on and take question number 4. Question number 2. A multiple choice test has 20 questions and 5 choices for each question. What is the probability of getting the next 6 questions correct by guessing? Now, since there are 5 choices, probability of getting one right, so let's say one right, let's call it right, is 1 over 5, correct? Now we want to get 6 in a row right. So probability of getting 6 correct in a row will be 1 over 5 to the power of 6, correct? So that is your answer. So we can write this as 5 to the power of 6 equals to, we'll write 1 over 15625. Question number 3. Determine the probability that at least 2 people from 20 will be born in the same week. Now, at least, the important thing here is at least 2 people from 20 will be born in the same week. So let's define our event A, where they are born in different weeks. Correct? So the sample space in A will be how much? Well, the first person has 52 weeks, second will have 51, right? So on. So this is, these numbers will go up to 30, right? So there are 20 students, right? So that is how it is going to go, which in short, we can write this as, so we can say number of cases here in the form of probability, permutations as 52 P20. Correct? So 20 of these, 52 P20 is the number of ways in which people are born in different weeks. Now we want probability when they are born, at least 2 people are born in the same week, right? So that means the probability of A prime, that is what we are looking for. So that should be equal to 1 minus probability of A. Correct? Now what are the total number of cases? So that is for A, probability that they will all be born in a different week. Total number in our sample space is that these 20 students, they all have a choice of 52 weeks, right? So 52, 52, 52, 20 times. So it will be 52 to the power of 20. So the probability of at least 2 people having the same birthday in the same week will be 1 minus 52 P20 divided by 52 to the power of 20. Correct? That is what we're looking for. So let's find the answer. So we have 1 minus 52 P20 divided by 52 to the power of 20. That gives us 0.985. Correct? So that becomes the probability that at least 2 people from 20 will be born in the same week. Correct? Let's move on and take up question number 4. Bob has 2 boxes with the contents of the boxes listed in the table. If he draws 1 ball from each box, what is the probability that they are both different colors? We don't want same colors, correct? We want different colors. So again, we'll use the complement as we used in the previous question. That concept is very important. So we can say 1 minus probability of same color. Perfect. So that is what we are looking for. Or 1 minus. Now what is the probability of getting the same color? So either it could be both red. So that could be one combination. same color, or we could get both green. Correct? So what is the probability of getting both red? Since in all, let's count how many we have in each box. 7 and 1, 8, and here the total is 12. Correct? So as far as the red balls are concerned, 3 out of 8, right? So we have 3 out of 8 times, both of them are independent events, so we can multiply the probabilities, right? 7 out of 12. This is for getting red. Correct? And how about green? It should be multiplied with green is 4 over 8 times 5 over 12. Since they are independent, we are going to add them up. So that becomes the answer. Correct? So which could be written as 1 minus 21, or let's use calculator. Or we can write like this. We just multiply. 21 over 96 plus, so we need not simplify. We'll use calculator later, right? So 20 over 96, which is 1 minus 96 is common, 41. So 96 minus 41, we can write. Over 96, that gives us 55 over 96, correct? So that is how we can find this probability. So probability, in this case, of different balls, different colors, is equal to 55 over 96. Perfect. Now let's move on and take question number 5. Snowfall. I hope you enjoyed the break. Now let's continue with the other interesting questions. Question number 5. In a tennis tournament, Mike and John play 3 games and John's probability of winning is 45%. Draw a tree diagram for 3 games. What is the probability that John wins all the 3 games? C. Determine the probability that John will win at least 2 games. D is determine the probability that Mike will win exactly 1 game given that John won at least 2 games. So let's begin with the tree diagram, and that is going to help us to answer the other questions also. So let me, this is a big diagram, a small space here. So let me begin like this. Okay, so let's say John, probability is 0.55. So the probability for Mike is going to be 0.45, correct? So now we'll say, let me write here J for John and M for Mike. So that is the first game. Now the second game, John may win or Mike may win, right? So if John wins, it is 0.55. It's going to remain same all throughout. And then the third game, John and Mike, we get 0.55 and 0.45. If Mike wins, so let's complete this part. Now here also we'll have similar situation. So that could be John and Mike, John and Mike. So that becomes the tree diagram. Perfect. Now let's answer the questions. What is the probability that John wins all the 3 games? So we are looking for this section. John wins all the 3 games. So it is 0.55 whole cube. Correct? So that is your answer. We have 0.55 cube equals to, in decimals, 0.1663. You can round it to 4. Let me write 75. Okay. C. Determine the probability that John will win at least 2 games. Now, what does that mean? When we say at least 2 games, that means John can win 2 games or 3 games. Correct? So that means John can win 2 games or 3 games. So the probability that it wins, let's write here, we'll just squeeze in. So it wins 2 games or 3 games. Now for winning 2 games, probability of John's win is 0.55. So it is 0.55 square and losing 1, that means, correct? So that could be written as, let me do it here. So it is 0.55 square times losing 1, which is 0.45. Correct? So that is winning 2 games and losing 1 game. Now this can happen in 3 different ways, right? That is to say, JJM, that is one possibility. The other is JMJ, right? One we have MJJ. So these are the 3 possibilities, correct? Let me highlight these 3 possibilities. So it could be JJM, or it could be JMJ, correct? Or he could lose 1 and win the other 2. So we'll multiply this by 3. You get an idea. So these are the 3 ways in which John wins 2 games. And one way, of course, which we have seen earlier, that he wins all the 3. So that is at least 2. So we'll add 0.55 whole cube. So that gives us the answer. Now let's calculate the value. 3 times 0.55 squared times 0.45 plus 0.55 cube equals to, in decimals, 0.57475. Okay? So that is the probability that John will win at least 2 games, right? So it could be JJM, JMJ, or MJJ, right? So these are the 3 ways, or all 3 wins by John, correct? Part D here is, determine the probability that Mike will win exactly 2 games given that John won at least 2 games, right? So given that this probability has happened, Mike wins exactly one game. So that is what the question here is. So how to answer this question? Well, the probability for for A to happen. So let's say the probability that Mike wins. So probability that Mike wins is A, let us say, right? So probability A is Mike wins, right? And the probability B be that John won at least 2 games. John wins at least 2 games. So now we have to figure out a conditional probability in this particular case. That is to say, probability that Mike wins when it is given that John has won at least 2 games. Now this probability is the ratio of probability of A intersection B divided by probability of B. Okay? Now what is the probability that A and B wins? So the probability of A and B wins is, that is 2 games, right? So John won 2 games, at least 2 games, is 3 times, since John has won at least 2 games, it is will actually take only this part, right? Since it is winning of John combined with winning of Mike once and for John 2 times. So the intersection will not include the 3 wins by John. You get the point, right? So therefore, this has to be 0.55 square times 0.45, and that could happen in 3 ways, right? Divided by probability of John winning at least 2 games, which we found as 0.57475. You get the idea, correct? So that is how you are going to find this value. So let's calculate. So we get 3 times 0.55 square times 0.45 equals 2, and we are going to divide this by 0.57475. I hope this concept is absolutely clear, right? So in decimals, this value is equal to 0.710. So that is equal to 0.7105, correct? So this is very important. So let me write here answer. You should do your calculations and check, right? 0.7105 is the probability that Mike will win exactly 1 game given that John won at least 2 games, right? So I hope you understand this concept, why we took only these 3 options, not the 4th one where John wins all the 3 games. Perfect. Okay, so with that, we have completed question number 5, which was kind of tricky. Now let's move on to question number 6. Question number 6. A fruit stand has 5 apples, 8 peaches, 4 plums, and 6 pears. If you pick 4 pieces of fruit at random, what is the probability that you select all peaches? So all peaches, let's call an A. In our case, for selecting all peaches will be, there are 8 peaches, we have to select 4, right? So from 8, choose 4. Remember, it's a case of combination. It doesn't matter which piece you picked first, correct? As far as the total is concerned, let's do it separately here. Since we are going to use this total in our sample space, number of fruits is how many? We have 5 plus 8, which is 13, plus 4, plus 6, that is 10, 23, correct? So in our sample space, the total number of choices we are picking up 4 is going to be from 23 choose 4. Let's find this number out. So it is 23 choose 4, which is 8855. Correct? So that is what we have to always divide by in our case. Correct? So we'll divide by this number, which is 23C4. So the probability for event A is 8C4 over, let me write 23C4, and then we'll calculate, right? So it is 8C4 divided by 23C4, which is equal to 2 over 253. So that's our answer. Second, let's call this as event B, right? Okay. What is the probability you select exactly 2 apples and exactly 2 peaches? So 2 apples from 5 apples. So 5C2, correct? So that is what you do. And 2 peaches from 8 peaches. So 8C2. So that is your favorable cases. So in this case, the probability of event B is going to be how much? All this divided by 8855. Correct? So we can do 5C2 times 8C2 divided by, let me write 23C4, makes more sense, and calculate. So we have 5C2 times 8C2, and we are going to divide this by 23C4, which is 8 over. So the probability of event B is 8 over 253. Okay. Now probability of event C. What is the probability that you select at most 2 apples? Now that is tricky. So when we say at most, that means as far as apples are concerned, let's write down here. So as far as apples are concerned, you could select 0, you could select 1 or 2. So that means at most, right? So others will be selected otherwise, right? So that means if out of 4, 0 apples means 4 others, 3 others and 2, these are others. Does it make sense? Correct? So that is a choice which you make. Now we need to find all these sample spaces, correct? So in this case, the favorable outcomes for option C are that you don't choose any apple, right? So out of 5, you choose 0 apples, but you choose other things. So out of 18, you select 4. So out of 5, choose 1 apple, and out of 18, choose 3. Out of 5, choose 2 apples, and out of 18, you choose 2. So that becomes the numerator for your probability, correct? So the probability for event C is basically all this, right? So we'll just write this over our sample space. Is it okay? So that is what it is going to be. So we're going to calculate all this and then divide by 8855, correct? So let's do it. So we have 5C0 times 18C4 plus 5C1 times 18C3 plus 5C2 times 18C2, right? All this in the numerator, which is 8670, divided by, we have already calculated that number 8855. We'll do that, correct? So we'll divide this by 8855 to get our answer, which is 1734 over 1771. So that is how we are going to calculate. So I hope all the steps are absolutely clear. So have a good look at it and then move on to question number 7. Question number 7. The probability of Anil hitting bullseye is 70%. How many arrows should he shoot so that the probability he hits the bullseye at least once is greater than 0.995? Correct? You can always pause the video, answer this question. Here is my suggestion. So we are looking at this target, right? So we have to hit this point. Now probability of hitting this is 70% for Anil. Now when we say how many arrows should he shoot so that the probability he hits the bullseye at least once is greater than 0.995, is greater than 99.5%. So what we should be looking for here is n failures before a success. So that is kind of key to understand this. Correct? So the probability of failure, we can say, so let's call this event as probability of failure in this case will be, since success is 70%, right? So probability of failure will be 0.30, correct? Since probability of success is 0.7. Is that okay? So failure is like 1 minus, right? So it is basically equal to 1 minus 0.7, which gives you 0.3. Now when we say how many arrows should he shoot so that the probability he hits the bullseye at least once is greater than 0.995, correct? That is, there could be n failures but one success. So we are looking for here, we are looking for n failures. So probability of n failures will be how much? It will be 0.30 to the power of n. Correct? Now after these n failures, we get a success, and that is what we are interested in, right? So now we get to our event, which is how many arrows should he shoot so that the probability he hits the bullseye is at least once. One success will be 1 minus these failures, will be equal to 1 minus 0.30 to the power of n. You get an idea. So that is how you get your probability. Now we need to figure out the value of n, and we are given the condition that this particular probability should be greater than 0.995. You get the idea. So that is how we get our equation. So we need to solve this equation and find n. Perfect. Now let's see how to solve this equation. So we'll do it here. We have 1 minus 0.3 to the power of n greater than 0.995. Taking this on the other side, we get minus 0.3 to the power of n is equal to 1 on this side, 0.995 minus 1, correct? Now, both are negative quantities, correct? Which is, we are saying minus 0.3 to the power of n is greater than minus. So that gives you 0.005. Now, if I multiply by negative, I have to interchange the signs. Do you see that? So we get actually 0.3 to the power of n should be less than 0.005, correct? Now to solve this equation, we have to take log both sides, right? So we'll take logarithms. So let's continue. Taking log, we get log of 0.3 to the power of n should be less than log of 0.005, right? So that gives you n log of 0.3 should be less than log of 0.005. Now we have to divide by 0.3. So we have log of 0.005 divided by log of 0.3. Now you should notice one thing, that we are dividing by a negative quantity. Remember, log of 0.3 is less than 0, right? It is negative. Therefore, you should change the sign. Now this is most important thing to understand, right? So here we have to now change the sign. You get the idea. Since log of 0.3 is negative, right? Now let's calculate. So we have log of 0.005. We have to divide this by log of 0.3. So we get 4.4, right? So that means this is 4.4. So we get n is greater than 4.4. So the whole number which is greater than 4.4 is 5. So that implies that n equals to 5. Does make sense to you? So that is how you're going to find your solution. So how many arrows he should hit? He should shoot 5 arrows. To ensure that the probability of hitting the bullseye is 99.5%. Perfect. So that is how you have to solve it. So the key things here to remember is that whenever you multiply by a negative quantity, you have to change the inequality sign, and also log of a number less than 1 is negative, right? So what we have learned here is log of n, where n is, let's say, greater than 0 but less than 1. In that case, log of n is less than 0, correct? Where n is between 0 to 1. So that is kind of important to understand, right? Now let's move on and take question number 8. Question number 8. A standard deck of cards is shuffled and 10 cards are placed on the table in a row. Your younger brother turns up these cards before you could stop him. Second card, ace of clubs. Fourth card, 3 of diamonds. Fifth card, 3 of clubs. Seventh card, king of hearts. Ninth card, queen of spades. And 10th card is 9 of clubs. Knowing the cards that your brother turned over, what is the probability that the first card is heart? Now, before we begin to answer these questions, let's understand one thing, that we have 6 cards which are open. So we have 6 open cards. Correct? So total of 52 minus 6, which is equal to 46, not open. Now that should help us to answer most of the questions. Second is, since we are given like second days, so for better understanding, what I've done here is I picked up these cards from the deck, arranged them as described. So that really helps you to answer the question. So that is the situation, correct? So in a way, we have second clubs ace, fourth diamond 3, fifth clubs 3, sixth, seventh king of hearts, ninth and 10th are queen of spades and 9 of diamonds. Now we'll keep this in mind as we answer our questions, correct? Does it make sense to you? So it becomes slightly simpler. Okay, so I'm going to keep this hand on the side. What is the probability that the first card is hearts? Now from the open cards, we have one heart, right? Which is, we already have one heart, which is king of hearts. So what is the probability that the first card is heart? So out of 13, we have already taken away 1. So we are left with 12, correct? So the probability is 12 out of 46, right? So we have 46 left. And as far as the hearts are concerned, only 12 are left, right? So we have 12 over 46 as the answer. Does make sense to you, correct? Now let's look into part B, which is, what is the probability that the third card is a face card? Now, as far as the face cards are concerned, how many face cards do we have? And how many are already open? Well, we have 12 face cards, correct? King, Queen and Jack are the face cards of 4 suits. So we have 2 of them already here. So 12 minus 2 is 10, right? So 12 minus 2 is 10. So we have 12 minus 2, which is 10 divided by 46. So that gives us 10 over 46 as our result. Okay? We will simplify them later to the lowest terms. First, let's get the answers. Now part C is, what is the probability that the third card is a club and the sixth card is a diamond? So that means these are 2 independent events we are going to multiply, right? So we are going to multiply with clubs and diamonds, right? So we want third card is clubs. How many clubs do we already have here? So as you can see here, we already have 3 clubs, right? So from 13, we have taken away 3. So let's say 13 minus 3. So the probability of getting club will be that divided by 46. Now once you get a club out of it, then we are only left with 45 cards. And we have to select a diamond. And how many diamonds do we have? Only 3 of diamonds has been taken away, right? Only 3 of diamonds is here. So 12 are in the deck. So here, out of 13, 3 of diamonds has been taken away. So that becomes the probability of getting diamonds, right? So this is 10 over 46 times 12 over 45. So I hope you understand the concept. That is how we have to answer this particular question, correct? Now you can simplify them and write down in the lowest terms. Dividing by 2, we get 6 over 23. Dividing by 2, we get 5 over 23. Here, you could simplify this a bit. So you could divide this by 2. You get 6 and you get 23 here, right? Divide these by 5. Okay, let's use another ink. 5 times 2 and 5 times 9. And 6 times 3 times 3 times 2 gives us 6 and 3 times 3. So we get 4 over 69 as our answer, right? 4, 2 times 2 and 3 times 23 is 69. So we get 4 over 69 as answer for part C. Is that clear to you? Correct? So we have our solutions for each. This is 6 over 23 and B is 5 over 23 and C is 4 over 69. Is that clear? So that is how you could answer this particular question. We are almost at the end. I hope you enjoyed this journey and some of you are still with me. Here is question number 9. A survey was conducted to determine the watching preferences of TV shows. The following results were obtained. 20% watched DD, 16% watched IF, 14% watched JJ, 8% watched DD and IF, 5% watched DD and JJ, 4% watched IF and JJ, and 2% watched all 3 shows. If a person is selected at random from this group, then what is the probability that the person did not watch any of the shows? Well, to move further, we should actually make a Venn diagram and understand the situation. So let me draw these circles and then we'll work with the numbers. So three things, DD, JJ and IF, so I'll make three circles, right? So let these be the different colors representing them. Okay, one more to go. So we'll draw like this. Now whenever you have a Venn diagram, you have to start with the value which is right inside, right? So let's say that's our sample space. Okay. Now let's begin by placing these numbers one by one. So we'll start from who is watching everything, right? 3 shows is 2%. So we'll just write numbers and 2%, which is right there, 2%, which means 0.02, right? So that is the intersection of all. Now we are saying this is DD for us, okay. So this is DD, and then we have JJ, and then we have IF. Correct. So these are the 3 shows. So 2% inside. Now, we are moving in this direction. So I hope you understand. What we are doing is 2% watch all. Now we'll go in this reverse direction. 4% watch IF and JJ. So this 4% watch IF and JJ. So there we already have 2% common. So to make it 4, I will write 2. Do you see that idea? So that makes us 2 plus 2 as 4. Perfect. Now, DDJJ is 5%. DD and JJ is 5%. We have 2 here. I have to add 3 to make it 5. Got it? So we got this. Now, DD and IF is 8%. So DD and IF is 8%. 2 is already there. I have to put 6 here. So it helps, right? So we've gone up to this place. Okay, now, individually, 14% to JJ. So 14% to JJ, I already have 3 plus 2 plus 2, which is 7. And so 7 is left. So that is 7%. 16% IF. Now we have 10 here. We're left with 6. So 6%. 20% DD. So we have 9 and 2, 11. And we want to make it 20. So that is 9%. Is that clear to you? So first thing is make correct Venn diagram. Okay, now from here, so out of that, what is not there? So we'll just add all these percentages here and take away from 100, right? So total what we have here is 9, let's use calculator, 9 plus 3 plus 6 plus 2. So we have done this portion, now 7, 2 and 6. So we get plus 7 plus 2 plus 6 equals 2. In all we have 35. So the numbers inside are 35, correct? So if I take away from 100, how much do we get? 65%, right? So 65% do not really watch any of these shows, correct? Now we are in a good position to answer all these questions, but this is very important. Perfect. I hope that's clear. What is the probability that the person did not watch any of the shows? So that is 65%, right? So we got it. 65% is our answer. How did we find it? All we added, watching, take away from 100% and get your answer. B, the person watches only one show. So only one show means 7, 6 and 9 should be added, correct? So let's add this. So we have only one show, 7 plus 6 plus 9, right? So that gives you only one show, which is 22. So that is 22%. Is it okay? Now, persons watches either DD or IF. So DD or IF. So the whole group excluding 7%, right? So this is 35 minus 7. Correct? So that is how you get this group, which is 28%. Is that clear? D. Person watches DD. Given that the person watches at least one show. So DD out of at least one show means all 35. Correct? DD is 20, right? So it is 20 over 35. That is your answer, correct? So you could write this in fractions, dividing both by 5, we get 4 over 7 as your percent, or in decimals, we can use calculator or just divide. 4 divided by 7 equals to, in decimals, 0.57 or 57%. Correct? So that is how we can answer this question. I hope you find it simple and useful. Feel free to write your comments, share your views. If you have your test papers, you can share your test papers also with me. We can actually find a solution set for the same. Feel free to share my videos with your friends. All the best, and thanks a lot for watching my videos. Thank you.